Welcome Physics B students. Yesterday you did the oscillating particle lab, so we're going to do two things today. The first thing we're going to do is to discuss the oscillating particle lab so that you can finish the summary questions at the bottom of it and turn that in. And then the second thing we're going to do is go through some of the notes from the information we can learn from the oscillating particle lab. So by the end of the day, you should know the difference between frequency and period and how to find each. And how to find, like if you're given frequency, you should be able to easily find the period or vice versa. So we're going to start with the oscillating particle lab. If you don't already have that open, you should go into Canvas, into your drive, find the copy of the lab you started yesterday. If you haven't done the lab from yesterday, stop watching this video, go back, open up the lab assignment from yesterday, complete it up through the graph assignment, and then come back to the video to finish the summary. So I'm going to assume at this point that you are ready to go and that you have the oscillating particle lab open. You will also need, after we're done going over the lab, we're going to take some notes on frequency and period. So you will want a piece of paper handy to record the notes down. Unfortunately, we didn't have time to get the packet ready, so you don't have a spot in the packet to write it, but you should be writing it down on a piece of paper. It's not going to be a ton of notes. All right, let's get at it. So just a reminder, because these terms will come up, amplitude is the maximum displacement from the resting position. So in the lab you did yesterday, you had a mass on a spring that was vibrating up and down or moving up and down. And you might have a spring like this. When it's just sitting there, this would be its resting position right here. And then it starts to move up and down. It might get as low as here and as high as here as it moves up and down. The amplitude is the displacement, the maximum distance from the starting position or the resting position to either its highest or lowest point. So this distance right here could be the amplitude, or it could be this distance right here. And it really should be the same for each. And then another important term is the cycle, and that's one complete back and forth motion. So when you were doing the lab yesterday, you were supposed to time the mass. If this is its highest position here, you would want to record or get the cycle from the time it takes to go from the top all the way down to the bottom and back up to the top. Or vice versa, you could start it when it's at its lowest position and time it from the bottom up to its highest position, back down to the lowest position. So one complete back and forth if it's moving side to side, or up and down if it's moving up and down motion. You got to have the full up and down for a cycle. So then to go over the lab, you could have set it up either way. So I have two graphs here showing the two different ways you could have it. Make sure on your graph, and I did link, I told you I would, but I did link it a little later, a link to how to make a graph in Google Sheets. So if your graphs do not look exactly like either one of these two, you need to go back and fix it and then reinsert the correct copy of the lab or the graph. You should have the axes both labeled on the side. So on the x-axis here, I have it labeled with time. On the y-axis, it's labeled with time. The x-axis on this one is labeled with number of cycles, or you have number of cycles on the y and time on the x. You should also have a title with both variables. So this one says time versus number of cycles. This one says number of cycles versus time. You should also include the trend line and the equation. So you have to add the trend line and then show the equation up on the top. You don't necessarily need the equation, but it will make the summary questions a little bit easier because it will give you the slope and it will give you the y-intercept for each graph. So before we go into the summary questions, make sure on the front page you have like the background or the brainstorm section filled out. Make sure you have your question. Make sure you've written a brief description of what you were doing. So what variables were you changing? What variables were you measuring? And make sure your data table is completely filled out. And then you also want to have the graph inserted onto the top half. So correct the graph if you need to. You can always pause this video, come back to it if you need to fix it up before we move on to the summary questions. So now going through the summary questions. Question number 1 asks you what your y-intercept is and what's the meaning of that. So for each graph, some of these questions might be slightly, or for each version, depending on how you set it up, your answers might be slightly different for each of the 4 questions. So if you had either one of these graphs, if you look at my y-intercept, which is given to me at the end here, both of them have a y-intercept that is really close to 0. So any variance, the reason it's not 0 is because of some slight errors in my measuring of time. So I'm going to say that my y-intercept is 0. It's pretty close to it for each of them. And the reason why, the meaning of that, and this would be 0 seconds, by the way, and this would be 0 cycles. My explanation might be slightly different. So for this one, if my y-intercept is if I'm at 0 cycles, it takes 0 seconds. So my explanation for why my y-intercept is 0 for the graph for time versus number of cycles is 0 cycles takes 0 seconds. For the second way you could have done it, where if you changed the time and counted the number of cycles, 0 seconds, if you time for 0 seconds, you will have 0 cycles. So very similar answer. It just depends on what you used for your independent variable and your dependent variable. So in my first graph, I chose and had number of cycles as my independent variable. So I changed the number of cycles and I measured the time. So if I had done 0 cycles, I didn't actually do this, but if I had timed 0 cycles, it should be 0 seconds. Vice versa, on this graph, I changed the time, so I counted how many cycles in 2 seconds, how many cycles in 4 seconds, how many cycles in 6 seconds, 8 seconds. Had I counted how many cycles in 0 seconds, I would have had to have had 0 cycles. I couldn't have had any cycles in 0 seconds. So that's question number 1. Question number 2 asks you what your slope is. Your slope might be slightly different depending on what spring and mass you picked. But for this one, I'm getting a slope of 0.814. I'm getting that right from the value before the x. And then I need to add a unit for it. To get the unit, if you remember from physics A, you always take whatever is on your y-axis and divide it by whatever is on your x-axis. So this would be 0.814 seconds per cycle. And then for the other graph, where I had time as my independent variable, my slope is right here. It's 1.23. This unit would be cycles per second. So that's question 2. And that just means that for question 2, the meaning of this is it takes 0.814 seconds for 1 cycle. If you read the unit, it kind of tells you the meaning, 0.814 seconds per cycle. So it's 0.814 seconds for 1 cycle. This meaning is going to be 1.23 cycles each second. That's question 2. So your answer to question 2 will be slightly different. Your slope will probably not be exactly like mine is, but if you had your graph with time on the y-axis and number of cycles on the x-axis, your unit should be the same, but your slope value might be slightly different. And on the flip side, if you had number of cycles on the y-axis and time on the x-axis, your unit should still be the same, but your number might be slightly different. That's question number 2. Question number 3 asks you if your slope represents the period or the frequency. Now, we don't know the definitions of period and frequency right now, so here I'm going to tell you what the definitions are. So period tells us the number of seconds for 1 cycle. So since period is the number of seconds for 1 cycle, this first graph where my unit is seconds per cycle tells me my period. So period, because it's number of seconds per cycle. And then you can probably guess on this graph here, the frequency is defined to be the number of cycles for each second. Now, if you look at the meanings of these two, period is the number of seconds per cycle. Frequency is the cycles per second. Those are reciprocals of each other, meaning a reciprocal is where you flip one over. So the reciprocal of like 5 is 1 over 5. So 1 divided by the answer is your reciprocal. So what's nice about frequency and period is if you know the period, if you know the period, which we use as a t, we'll get to that in a minute, the frequency is just 1 over the frequency gives you the period, and then the frequency is 1 over the period. So for question number 4, it asks you to find the other one. So the period of this first graph is 0.184. If I want to find the frequency of that, the frequency is 1 over the period. So I'm going to do 1 divided by 0.814. And I got to use a calculator for that one. 1 divided by 0.814 gives me 1.229. And then on the other graph, to get the period, it's going to be 1 over the frequency. So I will do 1 divided by the frequency of 1.23. 1 divided by 1.23 gives me 0.813. And this I should put a unit after these. The unit for period is seconds, and the unit for frequency is cycles per second. I'll give you a different way of writing that in a bit. Now, if you notice my numbers, my frequency here is this pretty close to what I had here, and my period for this one is pretty close to that graph there, because I used the same spring, I used the same mass, I had it just going, I collected this data at the same time with the exact same system. So these are just reciprocals, and you can see that when I calculate the other one. So when I calculated number 4, I got my slope for number 2, and when I calculated my number 4 on the second graph, I got my slope for number 2 on the first graph. They're reciprocals of each other. So you'll just notice my graphs are flip-flopped. I have time here and number of cycles on my x. Here I have number of cycles on my y and time on my x, so I just flip-flop those graphs. So my slope is just the reverse or the reciprocal of each other in the two graphs. So you should be able to answer your questions 1 through 4 depending on which graph looks like yours. So if you made the number of cycles your independent variable, this is your graph right here. If you made time your independent variable, that's your system there. Now your slope values will be slightly different, but everything else should be about the same. So now, if you don't have a piece of paper handy, pause your video so you can go grab a piece of paper. We're going to record the definitions of period and frequency and a couple of equations in your notes, and I'm going to do 2 example problems for you as well. So go grab a piece of paper if you need to, and then come back and finish this up. All right, I already gave you the definitions for period and frequency. Period is the time for one complete cycle, and frequency is the number of cycles per second. The unit for period is seconds. Change it to pen. And the frequency unit is seconds or cycles per second, which we write as a hertz. And you abbreviate hertz HZ. So period unit is just seconds, or S, because it's the time for one cycle. We don't include the cycles in the unit, we just say it's the time. But since frequency is the number of cycles per second, it's cycles per second, but that gets abbreviated or rewritten as hertz for the unit of frequency. And we'll do some example problems and you'll see how I do that. Equations. So to calculate period, depends on what they give you, but if they tell you like the times and the number of, like the time and the number of cycles to get the period, which by the way, the abbreviation for period is a capital T. Don't ask me why. Frequency is an F. So period is going to be the time it takes divided by the number of cycles. And then frequency equation is going to be the number of cycles divided by the total time. If they tell you one or the other, you can do period is 1 over the frequency. So if you know the frequency, to get the period, you can just do 1 divided by the frequency. If you know the period, to get the frequency, you can do 1 divided by the period because they're reciprocals of each other. So once you have one, it's really easy to get the other one. And then 2 example problems to go through it. These are pretty easy calculations. You might need a calculator for some of the math, but it's not hard. So it says an electric toothbrush vibrates 90 times every second. So we want its frequency and its period. It doesn't matter which one you start with. I'm going to start with frequency on this one. So frequency we had on the other page, or the other slide. Frequency is the number of cycles divided by the total time. This math isn't going to be hard here. There are 90 cycles in 1 second. So 90 divided by 1 is 90, and it's cycles per second, which is a hertz. So we write it as Hz. That's the answer for that one. Now that I have the frequency is 90 hertz, when I go to find its period, I can do the fact that I know the period is 1 over the frequency. So 1 over 90 would give me 0.011, and that unit for period is seconds. And then the second example problem, gusts of winds cause the Sears building in Chicago to sway back and forth, completing a cycle every 10 seconds. What are its frequency and its period? So in this one, I'm going to start with period. Period is defined to be the seconds per cycle. So it says that it is 10 seconds for 1 cycle. So 10 divided by 1 gives me 10. So it's 10 seconds for my period. And then when I go to do the frequency, frequency is 1 over the period. So 1 divided by 10 seconds gives me 0.1. And the unit for frequency is the hertz, or 10 cycles, or 0.1 cycles per second. So those are your 2 example problems. So once you have all of this written down, make sure you go back and submit the oscillating particle lab from yesterday. If you submitted it yesterday and you think you made mistakes, feel free to edit it and resubmit it. I haven't graded those yet. And then there is another short practice quiz, and you can take that as many times as you would like to get a perfect score if you want. If you need a little help on either of those assignments, please don't hesitate to send me an email. We can set up a Google Meet and go through them together. And then tomorrow we're going to start looking at waves. Have a great rest of your day.